All right, what we're going to do now is we're going to practice calculating hydronium ion concentration, hydroxide ion concentration. We're going to start with this sample problem. It has 1.0 times 10 to the negative 4 molar solution of nitric acid, since it's been prepared in a laboratory experiment. Calculate the hydronium ion and the hydroxide ion concentration. All right, so let's go ahead and take a look at that. We'll start with, we know that we had 1.0 times 10 to the negative 4. 1.0 times 10 to the negative 4 molar HNO3. All right, so we know we have the concentration of nitric acid. Now, here's where the monoprotic, diprotic, triprotic, whatever comes in. In this case, one hydrogen makes this a monoprotic acid. So what that in general means is that whatever the concentration is of this acid, since it's monoprotic, is also going to be its hydronium ion concentration. So the hydronium ion concentration is going to be 1.0 times 10 to the negative 4. All right, so since we have the hydronium ion concentration, now what we're going to do is we're going to use that ionization constant, the self-ionization constant of water, to determine the hydroxide ion concentration. We know Kw, which is the self-ionization constant for water, is equal to the product of the hydronium and hydroxide ion concentration. And we know that at 25 degrees Celsius, that is equal to 1.0 times 10 to the negative 14 molar squared. All right, so the other part of this question was to solve for the hydroxide ion concentration. Now, in this particular case, we know that Kw is equal to 1.0 times 10 to the negative 14 molar squared, which is going to be equal to the hydronium ion concentration, which we know, times the hydroxide ion concentration, which is what we're going to solve for. All right, so we need to divide both sides by the hydronium ion concentration. Here. So these will cancel out, leaving what the hydroxide ion concentration is. We'll take that. Be 1.0 times 10 to the negative 14 molar squared. Divide that by 1.0 times 10 to the negative 4 molar. So this you can do in your head. I mean, that's, you just take 1 times 10 to the negative 14, divide that in your head, you can say that is 1.0 times 10 to the negative 10 molar hydroxide. So that is your hydroxide ion concentration. Now, what we learned before, this would be a acidic solution. It's got a much higher hydronium ion concentration, times 10 to the negative 4, compared to the hydroxide, which is times 10 to the negative 10. All right, let's do another practice problem. This practice problem is going to be, say you want to find the hydroxide and hydronium ion concentration for 1.0 times 10 to the negative 3 molar, 10 to the negative 5 molar HNO3. Okay. Now, I'm going to shorten some of these out. We still know that it's monoprotic, so we know the hydronium ion concentration is equal to what that concentration is going to be, times 10 to the negative 5 molar. All right, hydroxide ion concentration, on the other hand, what is that going to be equal to? We're going to use our equation for the self-ionization constant of water. Okay, and we know it's 1.0 times 10 to the negative 14 molar squared. We know we are solving for hydroxide. We know hydronium is, so we can go ahead and already know that we are going to divide both sides by the hydronium ion concentration, and that is going to equal the hydroxide ion concentration. Just cut a couple steps out of here since that are kind of obvious. So what do we find here is that's going to be 1.0 times 10 to the negative 9, correct? 1.0 times 10 to the negative 9. Again, we can do that in our head, but if you put that in your calculator, you will see that. So again, a high level hydroxide ion concentration. All right, so let's do one. What happens if there is something? I know this isn't diprotic, but it works kind of the same way. When you have CaOH2, it will dissociate, and you're going to get calcium, and you're going to get 2 hydroxides for every 1 mole of it. So if we have 1 mole of this, you're going to get 2 moles of hydroxide. For all intents and purposes, it's going to double the concentration of hydroxide. So say in this particular problem, we are going to have 1.0 times 10 to the negative 4 calcium hydroxide. Now we're going to know the hydroxide ion concentration. Why? Because calcium hydroxide will tell us that. We know that it's going to be doubled because of the 2 hydroxides. So we'll take 1 times 1.0 times 10 to the negative 4 molar, and end up with 2.0 times 10 to the negative 4 molar OH. Now, to get the hydronium ion concentration, we are going to use, again, Kw is equal to, now notice I write this all the time, especially for somebody who's just learning this. I think rewriting the equation for every problem is real helpful because it helps you get to know the equation. So we know that also writing the value for Kw, again, we know that that's the case. It's going to be 1.0 times 10 to the negative 14. We're going to divide it by the hydroxide ion concentration now, which is 2.0 times 10 to the negative 4. And once we do that, that will solve for our hydronium ion concentration. And we'll do that, and when I divide the 2 that we have here, 1.0, and I divide that by, you're going to have to use your calculator, make sure you're putting it in correctly, times 10 to the negative 14. Go ahead, 1 divide times 10 to the negative 14 divided by 2. We are going to find that the hydronium ion concentration is going to be equal to, go ahead and put it in your calculator, 5.0 times 10 to the negative 11 molar. All right, so that is just doing a couple practice problems with determining hydronium and hydroxide ion concentrations. Now it's time to move on to calculating pH.